Okay, so now we want to be able to factor trinomials. And we're going to factor by trial and error. Now, when I was a kid, I don't know how old I was, but we always just factored by trial and error. We just kept trying until we got it. Now they teach other methods. This textbook, not so much, but in the next video, I'm going to show you another method that you might be familiar with. Most of the time, trial and error is going to be your best bet. It'll be quickest and fastest, and that's a pretty good method. Okay, let's say we have a trinomial x squared plus 7x plus 10. The idea behind trial and error is, well, can I come up with two numbers that multiply to be 10 and add to be 7? And the answer is I can. Now, when you're thinking about the 10, you're probably thinking, okay, what times what is 10? Probably 2 times 5. Okay, and so you can do that. If you think about the x squared, that's got to be an x times an x, right? And then plus 2 and plus 5. Now, that's the answer. How did I get it? Well, I've been factoring many years, and I just knew that that was the answer, which is a little unfair, I guess. But I look at the 10. I want two numbers that multiply to be 10, the last number, and add to be 7, the middle number. Okay? All right, now, what if I'm not telling you the truth? What if I did it wrong? How do I know? I can check it by FOILing. So first would be x squared, the outers would be 5x, the inners would be 2x, and the last would be 10. Does 5x plus 2x make 7x? Then yes, it checks, and this is the answer. Now, when we're factoring, we don't care if you put x plus 2 before or after the x plus 5. That doesn't matter to us. Multiplication is commutative. Okay? So we think of numbers that multiply to be one thing and add to be something else. All right. So we're going to try two more examples here. I have x squared plus 6x plus 8. And I want two numbers that multiply to be the 8 and add to be the 6. Okay. Now, some of you have done factoring before, and maybe you've seen the big X method. I'll talk about that in the next video. Okay, are there two numbers that multiply to be 8 and add to be 6? Were you thinking 2 and 4? That's what I was thinking. I think that'll work. X plus 2 and x plus 4. Now, a tip, if both the signs, if these are both positive, they're both going to be positive in your factors. Okay. But let's check it and make sure we're right. The first are x squared. Now, how am I getting the first? That's x times x. How do I get the outers? X times 4. Oh, I already had the plus in. And then the inners, I feel like these arrows get in my way, but it helps show you what we're doing. And then 2 times 4. And then that 4x plus 2x makes the 6x. That's what we were looking for. And then we have the 8. So yes, this is the answer. It all checked out. It is multiplication, and so it's factored. It's stuff times stuff. All right, now let's look at one more here. We want two numbers that multiply to be 40 and add to be 13. Now, I'm going to tell you, sometimes you're going to do this and you're going to be doing it right, and you're going to be like, I cannot come up with two numbers that'll do that. What I tell students to do is start at the beginning and just come up with all the possibilities. Remember, we're talking about integers. So it could be 1 times 40. Does that add to be 13? What's 1 plus 40? Well, it's not 13. Okay, so try 2. 2 times 20. Does that add to be 13? No, but I'm getting closer. Does 3 go into 40? No. 4 times 10. Does that work? 4 plus 10? No, but I'm getting really close. Does 5 go into 40? 5 times 8? Ah, 5 plus 8. That's 13. Okay, so it's going to be 5 and 8. We say we exhausted the possibilities. We thought of all the integers that go into 40, and these are they. Those are the combinations. There were 4, options here, but only one of them matches up to adding to 13. So my answer is going to be x plus 5 times x plus 8. And then we can check that with FOIL. We know it's right, but x squared plus 8x plus 5x plus 40. It's always good to check. Yeah, so it checks. Okay, more in the next video.